Hello students. So let's go for quick revision for finite potential in a quantum mechanics. So this potential is given by that Vx is equal to 0 and x is between minus a by 2 to plus a by 2 and V naught otherwise. So this is my potential and this is symmetric about x is equal to 0. So one thing you should know that parity is going to conserve. So parity is conserved. So that means my wave function will be odd and even. So we can have two type of wave function and we have to solve the Schrodinger wave equation in all three regions. So this is region 1, this is region 2, and this is region 3. So in a region 1, we have wave function psi 1 and that will be, let's say, a e to the power gamma x. This is x is less than minus a by 2. And in region 2, we have odd wave function as well as even wave function. So we have, we can have cos wave function. So something cos kx, let's say this is b cos kx for the even, and for the odd case, we can have, let's say, c sine kx, and these two are the wave function for region 2. We have learned all this thing, how in a even case it is coming and it is coming in odd case, means even parity and odd parity. So this will be between minus a by 2 to a by 2, and our psi 3 is basically, we can say, some d e to the power minus gamma x. And the value of gamma is here root under 2m v naught minus e upon h cut square. So this is my value of gamma. And the value of k is, hence my potential is 0 here and particle is free particle. So this will be 2m e upon h cut square. We can see that ground state wave function will have some cos function. The first excited state wave function will have some sine function, and here we have e to the power minus gamma x. Here you can say e to the power minus gamma x. So this is odd and even function. If the ground function is even, first excited state is odd, and then so on, we can have this particular thing. So this problem can be easily solved with the graphical method. And in the graphical method, we have to just calculate the value of basically eta square and xi square. So you remember all this thing. So we have eta is equal to gamma a by 2 and xi is equal to k a by 2. And we have to solve eta square plus xi square is equal to, we can easily calculate, that is mv naught a square upon 2h cut square. And for the odd case, we have condition eta is equal to xi tan xi. And for the even case, we have condition eta is equal to minus xi cot xi. And we have all the condition related, this thing are there, and we can solve it only with the graphical method. So what we have to do, we have to just plot eta versus xi. And this is my even case. And then at the pi by 2, you can start with odd case. And again, from pi, you have even case. And again, you have this particular odd case. So this will be 3 pi by 2. And this is plot of tan. This is even case plot, and this is odd case plot. And what is condition? The condition is all about what is this is nothing but the equation of circle, and this will tell you about the radius of circle, which is also tell about the strength of potential. So as your strength will increase, you have more and more bound state. So for the one bound state, two bound state, you should remember the condition, and this condition is very important, and you should just focus on this particular case. So if this is the case, then we have basically, if R is between 0 to pi by 2, then we have only one bound state. We have only one bound state. If R is between pi by 2 to pi, then we have two bound state. So this is condition for two bound state and so on. So we have all this, again, discrete number of bound state, but we should always remember the energy of finite box will be, corresponding energy of the finite box will be less than corresponding energy of the infinite box. So, and I am just talking about corresponding energy, means I am talking about comparison to ground, first to first. So you can, we have also discussed this thing in our class. And this thing you have to at least remember. You have to remember that there is finite probability that particle can be found outside this box. So there is finite probability. There is finite probability that particle is outside of box. So in a infinite potential box, particle is trapped inside box, but in a finite box, it can just tunnel down outside here also. And you should remember that parity is conserved. So ground state is even, first excited state is odd, and again then you have even and odd corresponding thing are there. So this thing you have to remember. Mainly most important thing are these three things. Once you know what will be the radius, if someone will give you potential in, and then you can easily say how many bound state you can find here. So you should just focus on these things. We have done a lot of problems based on this particular thing, and on the same basis you have to also go for semi-infinite box also. So for the semi-infinite box, we can just go for next level. The same concept is there, but little bit different wave function and little bit different calculation is also there. So let me just discuss in a brief manner what will be semi-infinite box. So in a semi-infinite box, this is my potential and this is infinite potential. Let's say this is a value and this value is V naught, and here is my potential is 0, and we are talking about bound state. So yes, we are just talking about bound state, means energy is always between 0 to V naught. So particle is trapped inside the box for the finite as well as semi-infinite. So you should remember all this thing. So here we have psi 1x is equal to 0 and psi 2x is equal to, let's say, a sine kx. There is not any cos function. We have done all this thing in our class. And psi 3x is equal to b e to the power minus gamma x. And again, we have gamma is the same value and k is the same value. But here we have boundary condition and we can change our boundary condition. We have only odd boundary condition. So if we will calculate eta square plus xi square, then this value is 2m v naught a square upon h cut square. And here eta is equal to minus xi cot xi is the thing. And we have to plot eta versus xi, and it will start from pi by 2 and then it will go for 3 pi by 2. So you should see there should be minimum some value of v naught such that you can have at least one bound state. So again, we have go for the same condition for the, this is nothing but the equation of circle and this is eta, and for the one bound state, at least you should have potential the value of radius should be equal to pi by 2. So let's directly go for what should be condition for radius. The condition for radius is between obviously pi by 2 to 3 pi by 2. We have one bound state, and then we have radius is equal to 3 pi by 2 to 5 pi by 2. We have two bound state, and you can have wave function. The wave function is sine function, so it will be sine, and there is tunneling property. There is the wave function can be tunnel in the classical forbidden region also. So this will be sine wave function, and this will be e to the power minus gamma x wave function, and this is the value of k. This k is again same value. So we have done these all thing in our class, and we have also solved a lot of problems, but you should focus these all thing at least once, and if there are some problem, they will surely ask what should be the wave function into different region, and what should be the conditions such that you will get the bound state, number of bound state, and this will all depends on what is your radius. So students, just focus on this thing. This is very beneficial at the for the point of view of examination. So just revise it properly. Thank you.